This lesson's on 3.3 rules of differentiation. So we're going to go over the 7 rules of differentiation. The first rule is the rule of constant. When we have a derivative of a number, it always equals to 0. So this is really easy. Example number 1 we have is a number which is 5, is constant. And if I take the derivative of a constant, we said it was equal to 0. Okay, so that's pretty easy enough. And rule number 2 says the power of a positive exponent. So I have then is x to the nth power is going to be some kind of exponent that is positive, and if what the rule says is I'm going to bring the n down, so we bring it down as a constant, and then we're going to subtract 1 on the exponent. It's always minus 1 on the exponent, okay? So let's take an example. Example number 2 says that I have y is equal to x to the 9th power. So same rule applies. We're going to bring the 9 down, and make it a constant, and then we're going to subtract 1 on the exponent. So that leaves me then 9x to the 8th power. Okay, rule number 3 is the power of negative. So now this is the opposite. We're going to have a negative exponent instead. So let's take something that is a negative exponent. Still, the power rule is still the same as the previous one. We're going to bring the negative this time n down, so that becomes a negative n, and we're going to subtract 1 on the exponent. So just be careful of here, because you're going to have obviously more negative or positive depending on the number that we have right here. Okay? So the example that we have then is negative 7 is the exponent. So I'm going to bring it down, just like my n right here, and then I'm going to subtract 1 on this. So negative 7 minus 1 is negative 8. Good. So this is going to give me negative 7 as the constant, because I brought that down, and we have this negative 8. Okay? Next rule. Rule number 4 is the constant multiple, which basically says that I have a number, a constant, and then I'll have a variable. We only take the derivative of the variable, we leave the constant alone. Okay? So an example of this is then I leave my 7 alone because that's my constant, but I take the derivative of x to the negative 3. This negative 3 is the same thing as the power negative rule that we did. So we're going to bring the negative 3 down, and then we're going to subtract 1 on the exponent. Okay, so now this is how I would write it. I would bring the negative 3 down, just like this right here, and I'd leave the 7. Now, I put the 7 in parentheses because I just want to remind myself later on, we're going to multiply these two numbers together, because if you don't, some of you guys may accidentally put negative 37 instead. Okay, so just be careful of that. And then I subtract 1 on the exponent right here, so we just have is negative 4. So I just need one more step, which is then to clean it up and simplify. So negative 3 times 7 gives me negative 21. Okay, next rule, rule number 5 is sum and difference, which basically says that I have two different variables or two different equations put together by a plus and minus. We treat each one individually as whatever the power rule is, if it's positive or negative or constant, we treat them individually. So I just take the derivative of u, which is whatever that may be, and then either a plus or minus, and then I take the derivative of v right there. Okay, so let's try an example. So the example is y equals x to the third plus x. So again, we treat each one of these individually. So we're going to take the derivative of x to the third, which is that positive power rule. So we're going to bring the 3 down, and we subtract 1 on the exponent, right? So that's going to give us then 3x squared. Now, here's a tricky one right here. I have an x right there, which then the exponent we know is a power of 1. Okay, so if I bring the 1 down and I subtract 1 on the exponent, I'm going to have is 1 minus 1, right? And 1 minus 1 is going to give us 0. Anything to the 0 power is equal to? Right, it's 1. Okay, so then we have is 3x squared plus 1. Good. All right, next one. Example number 6, rule number 6. So the product rule is the other one we have, and again, we're going to have is two different variables in this case. Now, this is different from this because this has a plus or minus attached to it, where this is not a plus or minus attached, but it's a multiplication problem. Okay? Now, this gets a little confusing as well because then we got a bunch of u's and v's and etc. And students usually get confused. So here's my trick on this. The word product is same thing as multiplying, right? So the letter u in multiplying, that's what you got to remember, because you're always going to copy the u first because it's multiplying, and you're going to take the derivative of v, so whatever that variable or equation may be, we're going to take the derivative of that, and it's always a plus when we do the product rule. And then we do the opposite. We copy the v and we take the derivative of u. Okay? So here's an example. So this is my u right here, x to the fifth, and my v would be then y to the second power. So again, this is multiplication or quotient. So we're going to copy the u first, which is x to the fifth. We're going to copy that, and we're only going to take the derivative of y squared, right? So that's going to give what? 2y, okay? And then we're going to put a plus right there, and then we're going to do the opposite. We copy the v, and we take the derivative of u. All right, so this is what it looks like. So then I have, again, is that x to the fifth. I took the derivative of v, then I copy the v, take the derivative of u right there. Okay? And then just one more step is to simplify it. Normally you put the number first and then alphabetical order on the variables. So since the 2 is right here, I'm going to bring it up in the front, and x comes before y alphabetically, so that's how we write it up here. Okay? Alright, last rule, rule number 7, which is the quotient. Now, quotient is the same thing as the word divide. So you guessed it, we're going to put v first because the word divide has the letter v in it. Okay? But here's the tricky part, and it gets a little messy, so pay attention to this. The numerator up here is going to be considered the u, the v is going to be considered the denominator. So as the word divide, we copy the v first, so whatever that denominator is, we copy the v, we take the derivative u, right? And then we do a minus. Now it's always a minus as far as the rules go, but again, this can change depending on this back part right here, okay? Then we copy the u, we take the derivative of v, all divided by v squared. Don't forget, this is a minus. I usually remember is because the big sign divide is like a big minus right there. So this is a minus, and so is this right here. Okay? So here's an example. Now I put this x to the third power of the denominator in red, so that way hopefully we don't get too confused because as you notice, both of these are variables of x's right there. Okay, so the rule says again, v first because that's divide, so that's the denominator. We're copying the v first. So we copy the v, we take the derivative u. This is the multiple one, right? So we treat each one individually. So it's x squared, which then gives us 2x. And then I have a plus normally, but the derivative of 1, which is a constant, is 0. So we're not going to put plus 0 because we're in calculus, okay? So don't put plus 0. We leave it as 2x. All right, next. Minus, because that's part of the equation right there. And then now we go the opposite. We copy the u, and I take the derivative of v, which then becomes 3x squared, okay? All divided by, and then again, that v squared right there, v squared. Okay, so that was the first, basically calculus right there. The rest is now algebra, which is then simplifying it. All right, so how do we simplify this? When we multiply this, right, you're going to add exponents, and you're going to also distribute in the second part right here. So this is what it looks like. If I multiply, we're going to get 2x to the fourth, because when we multiply, we add exponents, so 3 plus 1 is 4. And then on the second one, I just kept this minus right here, and I'm just going to clean this up by distributing this. So 3x squared times x squared gives me 3x to the fourth, right? And then 3x squared times 1 is 3. And we now have is then 3 times 2. Remember, if it's on the outside on the exponent, it's going to be the same thing as like distributing, which is multiplication. Okay, so then 3 times 2 right there. All right, so now we need to distribute this negative into this parentheses so we can drop the parentheses, right? So that's what's left right here. Okay, so we probably always want to combine like terms if we can. So in this case, I have x to the fourth here and x to the fourth, so I can combine those together. So 2 minus 3 gives us negative 1. So that gives me negative 1, x to the fourth minus 3x squared, all divided by x to the sixth. Now this is where a lot of you will probably stop right here and figure that's your final answer. But remember, anytime you work with fractions, you always have to reduce. So in this case, I can see that on the numerator, we could probably factor out some x, right? And then cancel it out with this x on the bottom. All right, so the most I could probably factor out is probably what, an x squared, just because that's the smallest that we have. So we're going to take out an x squared right here, we're going to factor it out, and that leaves me then at negative x squared, right, because I took 2 out of there, and then minus 3, because that x squared comes out right there, all over x to the sixth, which then if we reduce this right here, that's going to leave me negative x squared minus 3 all over x to the fourth as my final answer. Okay? So now let's go ahead and try some of these problems using the 7 rules of differentiation.